Good evening all. Today we're going to do Bayes' theorem, which is the third exercise of probability. Considering the deleted portion, this would be one of a very important topic. So Bayes' theorem, under that we have to know what is total probability, which is P of A equals P of E1 into A given E1 plus P of E2 into A given E2 and so on. So I'm not writing the summation formula. If a given sample space is divided into many events, if the given sample space is partitioned into many events, all the events put together is called as the total probability. Bayes' theorem. Bayes' theorem is 1 out of this divided by the total probability. So what is Bayes' theorem says? 1 out of this total probability will be your numerator and the total probability will be your denominator. So, in simple words, this plays the role of N of A and this plays the role of N of S. So N of S is the total probability and N of A will be one outcome of that. I'm not writing the way as it has been defined in the theorem using sigma and all that. I'm using my simple terms to explain this. So let's start with question number 2. I'm not doing question number 1 as of now because it's slightly different from the other questions. Choosing basic question in order to understand the concept better. Question number 2. A bag contained 4 red and 4 black balls. Another bag contained 2 red and 6 black balls. So there are 2 bags. Let us assume as bag 1 and bag 2. Put the number of balls under the bags. So bag 1 contains red 4 and black 4. Whereas bag 2 contains red 2 and black 6. One of the 2 bags is selected at random. So first we need to choose a bag and then a ball is drawn from the bag which is found to be red. Okay. A bag is selected, then a ball is selected and the ball happens to be red. So let me first fix it till here first. Let us find out the probability of drawing a red ball, which is considered as the total probability here. As I said there, they listed out the bags which is given, the balls in the bag. So total number of balls in bag 1 is 8. Total number of bags in bag 2 is also 8. Let A be the event of drawing a red ball. Let E1 be the probability of drawing bag 1. Let E2 be the probability of drawing bag 2. So first we need to draw a bag and then you have to draw a ball from that. So P of E1 is drawing the bag 1. Out of 2 bags, only 1 bag is bag 1. So 1 out of 2 chances. And P of E2 will also be 1 by 2. Now A is drawing a red ball. So A given E1 is drawing a red ball from bag 1. Bag 1 contains 4 red balls. So drawing a red ball from bag 1 is 4 out of 8. And drawing a red ball from bag 2, which is A given E2, is 2 out of 8. So what is the probability of drawing a red ball? Drawing a red ball. A indicates drawing a red ball. Probability of drawing a red ball can be done in 2 ways. Draw bag 1 and take red ball from that. Plus draw bag 2 and then take red ball from that. So 1 by 2 into 4 by 8 plus 1 by 2 into 2 by 8. This is the total probability of drawing a red ball. Do not cancel anything. Do not simplify anything as of now. Now, so I did till the red ball. The question is not over there. What is the probability that the ball drawn is from the bag 1? Now, go back to conditional probability questions. So this is a given statement to us and this is what we need to find. So what they want us to find is E1 given A. It is found to be red. What is the probability? It is from bag 1. Probability of drawing a red ball from bag 1 is this. So out of total probability, this case is drawing a red ball from bag 1, which will be the numerator. and denominator is the total probability. So E1 given A is P of E1 into A given E1 by the total probability. Then you substitute the concerned values. Try to take common terms out. I took 1 by 2 common out and I cancelled with this 1 by 2. Remaining is 4 by 8 by 4 by 8 plus 1 by 2, which is 6 by 8, and therefore we get 2 by 3. So this is question number 2. Now question number 3. Of the students in a college, it was found that 60% reside in hostel. 40% are day scholars. Previous research shows that 30 of all who reside in the hostel get A grade, and 20 of those who are day scholars attain grade. 20% of those who are day scholars will attain A grade. At the end of the year, one student is chosen at random from the college and he has an A grade. All right. So let's stop it here. What is the probability of a student getting an A grade? A student could be an hostler, or a student could be a day scholar. So then we need to select a hostler and then select a person of chances of a person getting a day, for A grade. Likewise for the day scholar also. So let E1 be selecting a hostler. Let E2 be selecting a day scholar. Let A be getting A grade. E1 is selecting a day hostler, which is 60 out of 100, 60%. E2 is selecting a day scholar, which is 40 out of 100. A given E1 is 30 out of 100. A hostler getting A grade is 30% as per the question. And a day scholar getting an A grade is 20%. Now, what is the probability of getting an A grade? A grade can be from a day scholar, A grade can be from the hostler. So this is the hostler's probability of getting a grade. This is the day scholar probability of getting a grade. So total probability will be sum of these two. Now what they want us to find in the question, what is the probability that the student is a hostler? So he is getting A grade. What is the probability he is a hostler? So which is P of E1 given A. P of E1 given A. So P of E1 given A equals P of E1 into A given E1 by the total probability. So 60 by 100 into 30 by 100 divided by the total probability value. Try to cancel the zeros, remove the hundreds. It's 18 by 26 and therefore it's 9 by 30. So next question number 4. In answering a question of MCQ, a student knows the answer or guesses. Let 3 by 4 be the probability that he knows the answer. Let 1 by 4 the probability that he guesses. So imagine that, put yourself in the place, then you will be able to understand. You will be able to answer 3 out of 4 questions which has been asked, and you will guess 1 out of 4 questions. So probability of knowing the answer is 3 out of 4 and probability of guessing is 1 out of 4. Assuming that a student who guesses at the answer will be correct with the probability of 1 by 4. So guessing and getting it right is 1 by 4. Because it's an MCQ, MCQ normally have 4 choices. So 1 out of 4 choices would be right. So guessing and knowing it right is 1 by 4. What is the probability that the student knows the answer? So let's do this first and then we go to the other. Oh no, what is the probability the student knows the answer given he has answered correctly? Now, let E1 be the probability of that he knows the answer. E1 be the probability of knowing the answer. E2 be guessing. Let A be getting it right. getting it correct. So P of E1 will be 3 by 4. P of E2 will be guessing. P of A given E1 will be knowing and getting it right. Well, there is no data about that. But if he knows, then he is right only. The answer have to be right. Do not think in any other way. So if he knows, he is right. So probability will be 1 here. And guessing and getting it right. Guessing and getting it right is 1 by 4. Now the question asks us to find, so what is the probability that he gets it correct? Total probability is getting it correct. He can know and get it right, or he can guess and get it right. So P of E1 into A given E1 plus P of E2 into A given E2, which is 3 by 4 into 1 plus 1 by 4 into 1 by 4. What they want is to find, given that he has answered correctly, what is the probability that the student knows the answer. So that means A given E1, which is P of E1 into A given E1 by P of A, the total probability. So answer would be 3 by 4 into 1 divided by 3 by 4 into 1 plus 1 by 4 into 1 by 4. So this is how we get the answer for the fourth question. Now let's not do the fifth right now. Let's go to question number 6. Question number 6. There are 3 coins. One is a two-headed coin, which means both faces are head. Another is a biased coin, in which chances of getting head is 75%. Third one is an unbiased coin, which means a normal coin where one side is head and the other side is tail. One of the 3 coins is chosen at random. It is tossed. It shows that it is a head. So what is the probability of getting head first? The head can come from the two-headed coin. The head can come from the biased coin, or head can come from the normal unbiased coin. So here also, let E1 be selecting the two-headed coin. Two-headed coin. Let E2 be selecting the biased coin, in which there is 75% chances to get head. Let E3 be selecting an unbiased coin. And let A be getting head. So P of E1, a 1 out of 3 coin is only two-headed coin. And P of E2, 1 out of 3 coin only a biased coin. And P of E3, 1 out of 3 coin is only an unbiased coin. So E1, E2, E3 are selecting 1 out of the 3 coin. Now A is getting ahead. So P of A given E1 is a two-headed coin showing a head. Probability is 1 for that. Because both the sides are head. The chance of getting head is 100%. Probability of A given E2. A given E2 is getting ahead in a biased coin, which as per the question says 75%, which is 3 by 4. And P of E3 is an unbiased coin, P of A given E3. P of A given E3 is getting head from an unbiased coin, which is 1 by 2. So probability of getting head is nothing but the total probability, which is P of E1 into A given E1, P of E2, A given E2, plus P of E3, into A given E3, which is 1 by 3 into 1, 1 by 3 into 3 by 4 plus 1 by 3 into 1 by 2. This is the total probability. Now let's read the last line of the question. What is the probability that it is a two-headed coin? So two-headed coin. So that is getting a two-headed coin, which is the first coin. So E1 given A. So which is P of E1 into A given E1 divided by the total probability. So that is 1 by 3 into 1 divided by 1 by 3 into 1 plus 1 by 3 into 3 by 4 plus 1 by 3 into 1 by 2. Simplify this, take 1 by 3 out, simplify, and then you get the answer. So next question number 7. An insurance company insured 2,000 scooters, 4,000 car drivers, and 6,000 truck drivers. The probability of an accident is 0.01, 0.03, 0.15. One of the insured meets with an accident. So let's do it till here first. Probability of an insured meeting with an accident. So let E1 be selecting a scooter driver. So P of, so if you want you can write all the events. So let E1 be selecting a scooter driver. Let E2 be selecting a car driver. Let E3 be selecting a truck driver. Let A be meeting with an accident. Meets with an accident. So P of E1 is 2000 divided by 12,000, which is 2 by 12. And then P of E2 is 4,000 divided by 12,000, which is 4 by 12. And P of E3 is 6,000 divided by 12,000, which is 6 by 12. Now P of A given E1 is a scooter driver meeting with an accident. The data says it is 0.01, which is 1 by 100. P of A given E2 is a car driver meeting with an accident, 3 by 100. And P of A given E3 is a truck driver meeting with an accident, 15 by 100. So these are the events. Now what is the probability that a person is met with an accident, which is P of A? Otherwise the total probability 2 by 12 into 1 by 100 plus 4 by 12 into 3 by 100 plus 6 by 12 into 15 by 100. So that's total probability. Now, what they want us to find, what is the probability that he is a scooter driver? So, they want us to find again E1 given A. P of E1 given A. So, P of E1 given A is P of E1 into A given E1 divided by P of A, which is 2 by 12 into 1 by 100 divided by 2 by 12 into 1 by 100 plus 4 by 12 into 3 by 100 plus 6 by 12 into 15 by 100. So you can cancel 12 into 100 straight away. The numerator will be 2, 2 plus 12 plus 90, and that will give you the book answer. Question number 8. A factory has two machines, A and B. Past record shows that machine A produces 60% of its item and machine B produces 40% of the items. So out of the total production, 60% is done by machine A, 40% is done by machine B. Further, 2% of the item produced by A and 1% of item produced by B were defective. All the items are put into one stockpile and then one of them is chosen at random from this. What is the probability? It is defective. So probability of being defective. It could be from the production, it could be from machine 1 or it could be from machine 2. Isn't it? Let E1 be selecting an item produced by machine 1. So output from machine 1, selecting an item from produced by machine A. And E2 will be output from B. A will be defective. So P of E1 is 60 by 100. P of E2 is 40 by 100. P of A given E1 is defective item produced by machine 1. Machine 1 produces 2% of the item which are defective, 2 by 100. And P of A given E2 is 1 by 100, 1 by 100. So probability of being defective is the total probability here, which is P1 into A given P of E1 into A given E1 plus P of E2 into A given E2. That is 60 by 100 into 2 by 100 plus 40 by 100 into 1 by 100. Now, the next part of the question. What is the probability that it is produced by machine B? So that is E2 for us. So they want us to find P of E2 given A, which is P of E2 by A given E2 divided by P of A, which is the total probability. So 40 by 100 into 1 by 100 divided by 60 by 100 into 2 by 100 plus 40 by 100. Obviously the 10,000 will get cancelled. The rest of it will give you the book answer. Ninth question. Two groups are competing for a position on the board of directors of a corporation. The probability that the first and the second group will win are this and this. So this is the first group winning and this is the second group winning. Further, if first group wins, the probability they introduce a new product is 0.7. The corresponding probability for the other team is 0.3. If the second group wins, find the probability the new product was introduced by the second group. Now, what is the probability that the scheme will be introduced? That is our total probability. So, let E1 be the first group wins. First group wins. Let E2 be the second group wins. And E1 and A will be introducing a new product. Introducing a new product. So P of E1 is first group winning, which is, as per the question, 6 by 10. And P of E2, second group winning, which is 4 by 10. P of A given E1 is group 1 wins and they introduce the scheme. which is 0.7 or 7 by 10. And P of A given E2 is 3 by 10. Now the question says us find the probability that a new product is introduced by the second group. So probability that the product is introduced, which is our total probability here. So P of E1 to A given E1 plus P of E2 into A given E2. So that is 6 by 10 into 7 by 10 plus 4 by 10 into 3 by 10. And what they want us to find? They want us to find E2 given A. Second group chances winning, and they introducing the new product, which is P of E2 into A given E2 by P of A. So 4 by 10 into 3 by 10 divided by the total probability, which is 6 by 10 into 7 by 10 plus 4 by 10 into 3 by 10. 10th question, which is an important question just like the ones that I left out. The 5th is important, the 1st is important, the 10th is important, the 12th is important. So first let's take the 10th question. Suppose a girl throws a die. She throws a die. If she gets 5 or 6, she tosses a coin 3 times and notes the number of heads. If she gets 1, 2, 3, 4, she tosses a coin only once and notes whether there is a head or a tail obtained. If she obtained exactly one head, so she is getting a head. So total probability is getting a head then. What are the ways of getting head? She can get exactly one head in 3 tosses of a coin, which she will do if she gets 5 or 6. Or she might get one head if she toss a coin only once. That she will do if she get 1, 2, 3, 4. So E1 is getting 5 or 6 when she throws a die only one time. And E2 is getting 1, 2, 3 or 4 when she tosses a coin, she tosses a die 1. And A1 getting exactly one head, getting exactly one head. So P of E1, a die contains 6 faces in which 2 faces are 5 and 6. So probability of getting 5 or 6 is 2 out of 6. And E2 again, a die contains 6 faces in which getting 1, 2, 3, 4 is 4 out of 6. Now in case if she getting 5 or 6, she is going to toss a coin 3 times. So that means the total number of event over there would be 8. A coin tossed 3 times will be 2 power 3, 8 event, like head, 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 tail, 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 head, head, tail, and so on. In that, what are the event in which we get only one head? Head TT, T head T, TT head. So therefore, 3 out of 8. P of A given E2 means she's getting 1, 2, 3, 4 and then she tosses a coin only once. So getting head is 1 out of 2. So probability of getting exactly one head, which is total probability, is 2 by 6 into 3 by 8 plus 4 by 6 into 1 by 2. So this is the total probability. Now, if she obtained exactly one head, what is the probability? What is the probability she throws 1, 2, 3, 4 with the die? So what they want us to find? They want us to find P of E2 given A, which is P of E2 into A given E2 by P of A. So the first set of probability sums, first set of Bayes' theorem questions are over. You can try the 11th one on your own. And the rest of the question I'll do it in the next video. Thank you.